Okay, stepping up our game even more now, finding the difference quotient of a radical function. This one's going to require a bit of a trick, which we have talked about before, just not in this context. Okay, I've taken down the difference quotient format, the f of x plus h minus f of x over h. That's something you're just going to need to quote unquote memorize. You just need to know that. That's not going to be given to you. Okay, if f of x is equal to the square root of x plus 2, to do the difference quotient, we need to know what f of x plus h is. Well, wherever x goes, that's where x plus h goes. So x plus h goes under the radical here. So when I write f of x plus h, make sure the 2 is not under the radical, f of x plus h minus f of x, right? F of x has 2 terms, so I need to make sure I'm putting parentheses around that. Okay, this is all over h. Now if I distribute the negative in here, I end up with the square root of x plus h plus 2 minus the square root of x minus 2 all over h. And we've talked about how we're supposed to simplify the numerator. And when we simplify the numerator, we want to have terms that include an h and nothing else, right? Well, in this case, the only things that cancel are the minus 2 and the plus 2. Okay, don't try to get crafty and say, well, I can subtract this. No, you can't. You can't do anything with this because those are both under the radical symbol. So simplifying the numerator in this case doesn't just mean combining like terms. We have to dig into our tool bag, into our bag of tricks, and figure out a way to make this simpler. Because it is imperative, doing a difference quotient problem, doing any of these, it's imperative that we cancel this h. All right, and again, I mentioned this before, but when we do this in May, when we start talking about limits, this is going to equal 0. And when this is 0, that's bad, right? So we need to get rid of this fraction that has a 0 down here. So it's imperative that we get rid of this. Now, combining like terms got us to this point. What more do we have? Now, we did this back again in our Algebra 2 review, but one thing we can do when we have a fraction with radical symbols in it, sometimes, and it varies the case that we're doing these in, sometimes it makes sense to multiply this by its conjugate. Okay, and we've used that word before. I'm going to use that word a ton more times. Because if you, with a product of conjugates, keep in mind, okay, remember this, x minus 2 and x plus 2. These are conjugates, right? They're binomials that have the same terms, one with a minus, one with a plus. The product of conjugates is the difference of their squares. So when I have radical symbols, I want to be able to square these, but we don't get to square them by just, putting a little 2 in the corner. We square these by multiplying by the conjugate. So I'm going to do that in the numerator. I'm going to take this front term, which is square root of x plus h, and I'm going to put a plus sign in between it and radical x. So this is the conjugate of this. But in a fraction, whatever I do to the bottom, or whatever I do to the top in this case, I also have to do to the bottom. Okay, so I end up with this expression. Now, I'm running out of room, so I'm going to jump back up here to the top. Okay, you don't have to erase your stuff, but I am. Okay, now what happens when we multiply conjugates? We get this term squared, which would just be x plus h, and we get this term squared, which would just be x, and we get a minus. This is the difference, ready? This is the difference of these two things squared. If I square each one of these separately, I get these, and we have the difference of their squares. Now on the bottom, it's a whole lot messier. Okay, we have x plus h plus the square root of x. It looks like this. All right, but from here, hopefully you see what's going to happen. What's going to happen on the top? X minus x disappear. I end up with a similar scenario that we've seen in the last example. In the last example with the rational function, I had an h on the bottom, and that h was being multiplied by something. So this h is a factor of the denominator. This h is not. This h is a part of this sum, which is a part of this sum. It's a big mess in here. I can't do anything with that. But this h is being multiplied by something, so I can cancel it. And I'm left with 1 over the square root of x plus h plus the square root of x. And if you're wondering, like, can we leave it like that? For now, we can. Okay, again, this is going to end up being a 0 down the road in May when we're talking about limits. And if that's a 0, this whole thing doesn't turn into 0 if this does, right? So there are other things that we can do. For the time being, I'm happy with this. We can leave this problem looking like that, okay? And then we'll worry about simplifying it later on down the road. But again, imperative that we cancel this h from the denominator, so we need to make sure we have an h in the numerator to do that with, all right? Thus ends our difference quotient review. The homework, oh, I should write this down. So hopefully you made it this far. The homework, I wrote this down for you. It's on the Google Calendar. It's page 185, numbers 61, 63, 74, and 76. Okay, those 4 problems on loose leaf paper turned in to me by the day of the test. Okay, by Tuesday. I've uploaded that page, I've copied it, or excuse me, I've ripped it out of my book, scanned it, and uploaded to Schoology. So even if you don't have your book, you can still do those problems. All right?